the active regions what we be able to see here in the corona, and then solar blast and coronal mass ejections. Okay, and then space weather. There is impact of solar blast and coronal mass ejection on the Earth's environment. Okay, and finally solar terrestrial relations, and then conclusion. And then the sun appears like this. So because the sun's brightness, normally we are not able to see the sunspots. Otherwise, if you project the image and then if you take the picture of the sun, then you will be able to see the presence of these active regions, and which appear as sunspots in the photosphere. Okay, and then the atmosphere of the sun. All these things are, you know, photosphere is also a part of the atmosphere, and then the next atmosphere, chromosphere, slightly lower to this level compared to this level. This is slightly lower, and here also you are able to see the magnetic features, different magnetic features. You can see the bright regions which are called as flagges, okay, and this dark thread-like structures, they are called as filaments. You can see these flagges, they are all sitting above the sunspots. They are all the active regions, flagges and as well as filaments. They are all the magnetic structures, okay, magnetic features that are visible in the chromosphere, okay, up in the chromosphere. And now this is the picture of the sun taken in the calcium K line. Okay, the rest of the wavelength they are cut off, and only the calcium K line is alone allowed for the sun. And then if you get the image of the sun, then the image looks like this. And here you will be able to see the similar features, bright features. You can see all these features are co-spatial. Are you able to see this? Okay, on the same day these photographs have been taken, and all these features are all co-spatial, but of course appear somewhat differently in photosphere, chromosphere, and as well as in the coronal regions. So these are all the active regions what we see there in the upper atmosphere of the sun, with the help of the calcium K filter, okay, or a spectrograph. And this one is the soft X-ray picture taken with the help of spacecraft SOHO, and here also you can see on the same day you can see the loops. These are all bright loops, appear darker mainly because these are negative, okay, and that's why they appear darker, otherwise they are bright, and they are all sitting exactly above the sunspots. Okay, underneath that you can see all these features, you can see the prospective sunspots. So the energy has been carried out and then deposited in the higher atmospheric levels, and enhancing the brightness in the atmospheric levels in the corona and as well as in the chromosphere. And this is the dark region because it appears brighter here, and as I told, it is a negative. Okay, so when I tried to convert it into positive, I was not able to do it, that's why I left it. Okay, and otherwise these regions are all coronal holes. Okay, and so all these active regions, they are directly involved or indirectly involved in the transient phenomena, okay, energetic phenomena that takes place there on the solar atmosphere. And that's why, first of all, before going into the transient phenomena, we should have the recap of the active regions that appear in different atmospheric levels of the sun. Okay. Now, for example, like flash or coronal mass ejections, and or even prominences, eruptive prominences, and all these transient phenomena, okay, short-lived phenomena. So they are all taking place in the corona. So, and though they are taking place in the corona, and the active regions in the photosphere and the chromosphere, they are responsible for triggering these phenomena in the coronal regions. Okay, so it's not that just like that it appears only in the corona. So it's mainly because of the active regions that are observed below the atmosphere, like the sunspots or the flagges or the filaments. Okay, so they are all responsible for triggering such transient phenomena in the upper atmospheric level of the sun and in the corona. So now let us try to see what are all the coronal features. Okay, so the coronal features, The Skylab satellites, they reveal interesting facts about the corona, and so some of the coronal features are coronal hole, coronal loops, prominences, solar flares, and coronal mass ejections. Coronal holes. So now the magnetic field is predominantly open in these coronal holes. You can see this magnetic field. It's totally dark, and another important aspect is they possess unipolar magnetic field. Okay. Another interesting thing is they have unipolar magnetic field. So these unipolar magnetic field, they are the places where the solar wind originates. Okay, solar wind at the speed of 1000 kilometers per second. Okay, they continuously, constantly they are flowing across. Okay, so they are all open field regions. They are not closed field regions. They are all open field regions, and so predominantly unipolar. Okay, so in fact solar corona, it extends, as I mentioned yesterday, it extends even beyond the Earth. Actually, Earth is immersed in the solar corona. Okay, and since the temperature in the corona is very high, naturally the pressure is high compared to the outer pressure, and that's why the corona flows outward. Okay, so it is the shape of it is the solar wind that shaped the tail of the comet, and as well as it creates what I can say, radiation belts around the Earth, like Magellan radiation belt, and so on and so forth, aurora and other phenomena. Okay. Now, these are all called as coronal loops. The first one what we have seen, coronal loops, some of the coronal features, and coronal loops, they are all closed magnetic field regions. You can see this closed magnetic field region. Sometimes they open up. So when they open up, then what happens is the material is thrown out. Okay, most of them, they are all having closed magnetic structures. You can see these magnetic fields, they are all closely knitted. Okay, very closely knitted. And so again we can see the coronal loops. Okay, coronal loops in the limb regions. That's why they look like this, extends. Okay, for example, if you are able to see in the what I can say, you can see this is coronal loops. Coronal loops. Underneath maybe a sunspot will be existing. Certainly a sunspot will be existing. Okay. So, and in the case of the chromospheric feature, if you see, bright charges will be existing. Okay, but the same loops, when it appears in the limb, then you are able to see these fine magnetic features. They are all magnetic field lines. So that is the flow of the gas, because it's all amplified gas, mainly consisting of ions. These ions will be freezing in along the magnetic lines of force. Agree? Okay, so these magnetic field lines, they represent the jets of gases, okay, flowing across the magnetic field lines. Okay, they are all tightly knitted, they are closed, and when they open up, then it is going to be some kind of tangent phenomena that we are going to see. From the trace, which is a payload of SOHO, now you are able to see very clearly the coronal loops. You can see how these magnetic field lines, as they are all material going into the magnetic field lines. Okay, so this material only they are going to be thrown out. Okay, sometimes, and so what is responsible for the eruption of this material from these closely knitted magnetic field lines? That we will see. The prominences. These are the prominences you are able to see. There are limb features appearing on the limb of the sun. Okay, so on the disk you are able to see them in the form of a filament. Are you able to see? Of course, even yesterday itself I told you that these filaments, they are all fused chains of fibers. Okay, which are for fibers. So these fibers, of course, they form the spicules. Okay, so these fibers, when they are all joined together, they are all fused together, then they appear as filament